Hello, hello. We are here to talk geometry. So get that page out and I'm going to go over that with you, share the answers with you so you can check up on it. Geometry is a heavy hit topic, so you want to make sure you are refreshed. First on this number one, your page may be cut off, so make sure this top line says R and the second one says P. You're trying to find the midpoint. I've done the midpoint formula right here in this green box for you. But just know, basically, if this is at 810 and this is at 12, -6, I'm looking at those x values and I'm asking myself, oh, what's the middle of them? So the first step you would need to do is to find point R by finding the middle of 810 and 12, -6, and I get 10 too. But if I read carefully, I'm supposed to be finding Q, which is the middle of these. I know the middle of 10 and 12 is 11, so I can stop right there and pick C. If you come down here to number 2, reflecting over the line y equals x would be this line right here, the perfect diagonal that goes through those being the same points, like 1, 1, 2, 2, 3, 3, 4, 4, because the y value and the x value equal each other. So it's a little bit harder to kind of count what's happening here, but I can imagine just folding my paper in half on this line and getting my coordinates. So for example, if B right here appears to be at what, 3, -3, then over here B would be at 3, +3, okay? Number 3 down here, I'm trying to find which of these would carry the parallelogram onto itself. Remember, that means put it back in the right spot. So a reflection across AC, I would have to draw a line segment AC, and if I folded that parallelogram in half, it's not a perfect diamond shape. So this point B is not going to match up where this point D is. Reflecting across EF would be me drawing a line right here, and if I folded this top part down, they're not going to match. Now, rotating about the origin versus rotating about the figure. If you rotate about the origin, you're turning the entire paper. 180 would be turning it upside down, and this parallelogram would end up down here in quadrant 3, what isn't right. But if I rotate about the center, that would be like me putting my finger right here and only turning the parallelogram 180 degrees, which would make it match. Up here on number 4, which would transform this into the image this, and you can see the 2 I marked there would get it back to the spot they wanted it to be at. Don't forget 270 counterclockwise would move it 3 quadrants, and obviously it only moved 2. Number 5 would be a very tricky question to actually do by hand. You could graph all these points on a grid, and if you're finding the perimeter, you're adding up all the sides. So technically, I would need to know, well, how long is the side from 1, 3 to 2, -3? And so I would have to use the distance formula. So I've written that down for you here. Don't forget, you can also do Pythagorean theorem, but these little hops I wrote up here are how long each of these sides are. I add them all up to get perimeter, and that's how I got 14. Number 6, I should not have put on the packet. It's a little too advanced for the amount of math that we know right now, so we're going to skip it. Number 7, what kind of quadrilateral is this? The easiest way to figure it out is just to graph it, which is what I did over here on this grid. And then I've just kind of reminded you what each of these shapes look like. A trapezoid is like a beheaded triangle. Square, all the sides are the same and has 90-degree angles. A rhombus, all the sides are the same, but it's slanted. Think slanty square. And so obviously this shape is a rectangle. All right, let's flip over to the back. Number 8, reflecting over the x-axis is like you folding the paper right here. That's what I did in green. And then reflecting over the y is like you folding on this line, and that's how you end up with the red. Number 9, it might be hard for you to see the shape there, but they like to ask a lot about how can you transform something back onto itself. You would do that by all of the above. Sometimes they give you specific letters for your vertices. In that case, it matters a lot more what transformation you do. But if it's just a blank figure, anything that gets it laying back on top of itself and looking the same will work. Number 10 and 11, so you're given these sides and you're told they're congruent respectively. That means whatever they listed first here, RS, matches up with what they listed first here, VW. That alone tells me R goes with V, S goes with W, so T must go with U. So I've drawn that out right here in this picture. Now, based on what they told me, these must be congruent because of side, side, side. To find what RST matches, I would just want to take that same path. R to S to T would match with V to W to U, making sure I'm going down the right sides. Back up here to number 12, filling in the proof. Biggest thing I can tell you guys is mark what they tell you. I have these parallel lines, so I know that first statement because it's given. I know 1 and 4 go together because they're alternate interior angles. I can look at where 7 and 2 are and see their corresponding angles. I know that 4, 7, and 3 are going to add up to 180 because they make a straight line. They make a straight angle. And then because I knew 4 and 1 were the same, I can swap them out. Because I knew 7 and 2 were the same, I can swap them out. So what I just did to prove that angle 1, 2, and 3, which form a triangle, add to 180, is because I substituted for equivalent parts that I already knew. And number 13, I'm told I have a rectangle. Now, there's a lot of great properties of a rectangle. I know they're 90-degree angles. The opposite sides are the same. I know the diagonals, these cut-throughs, bisect each other, which means that they are the same on both sides of this point E. So to find CD, I just look at the side opposite of it. I get 18. The measure of diagonal BD, this piece right here, would be 15 and 15 or 30. And there's that perimeter word again. If I want the perimeter of CDE, I'm adding up these 3 sides of this little triangle I colored, and you get 48. So hopefully that helps you with geometry. Good luck as you are finishing up your studying.